reunión?
Sí, hubo una dificultad con la conexión, pues.
Ya, no hay problema. Estaba indicando que en estos momentos va a dar su charla el profesor Pratap Kollu de India acerca de su avance de proyecto. A partir de ahora, cada mes va a haber 2 reuniones por mes de trabajo, 2 reuniones por mes de trabajo por el proyecto que tenemos que avanzar lo más pronto posible. No es necesario que usted, si tiene otras reuniones durante estos meses, no hay problema en el caso suyo, pero los demás miembros van a tener que presentar, al menos cada reunión, uno de los miembros va a dar una charla. Al final, hasta el final de año, cada miembro tiene que haber dado 2 charlas acerca del avance de su trabajo y el paper que va a presentar. Ok, el día de hoy va a dar un avance de su trabajo el profesor Pratap Kollu de India. Entonces, ¿quiere decir usted unas palabras para que empiece?
No, voy a estar atento a la exposición.
Ok, muy bien, gracias. Profesor Pratap, apague su micrófono, por favor, un favorcito, profesor. Ok,
Sí,
profesor Pratap Kollu, you can start now. Start, please.
Okay. So, good morning, everyone. Hope everybody is able to see my presentation. Luis, can everybody see the presentation?
Yes. Go ahead.
Okay. So, today I'll be talking about synthesis and characterization of iron oxide nanoparticles and making them a composite with graphene. So why? Because our part of the project lies in iron oxide. So if the project is divided into different countries, means our project. So finally what happens is that we'll get a chunk of steel pieces from China, and then so we are going to ball mill them, and we'll try to make them as composites, and we are trying to add graphene into it and make them as pellets and try to check whether they can go back into the steel input or not. So in parallel, what we are trying is, so we are synthesizing iron oxide nanoparticles, and we are comparing the synthesized nanoparticles and ball milled nanoparticles and trying to check out so how good are the particles so we have received from the original steel slag. So that is our aim, and let me start the presentation here. So I work on generally first few slides, they are introduction, means what is my research spectrum, so about my university and all this. And I have divided this talk into a brief introductory talk about general applications of iron oxide. First 4 or 5 slides, I'll explain about how the iron oxide we are getting can be used. Means not only for steel pellets and giving back to the steel plant. So we can use the iron oxide which we are getting from the steel chunks in different ways. So I'll explain about how they can be used in 4 or 5 slides. After that, how we have synthesized iron oxide and the graphene and then making them as a composite. So that's what. So here is my research spectrum. So my research spectrum includes magnetic sensors using giant magnetoimpedance, Hall, flux gate, and TMR principles. So these magnetic sensors are useful in navigation, biosensor, disease detection, and all this. So I work on composites also, that is nanocomposites, and the nanocomposites with 2D materials. So I work on batteries, lithium-ion batteries, sodium-ion batteries, supercapacitors, and multiferroids. So this is about my university. So University of Hyderabad is a central university. Central university means funded by directly Government of India. And 1 year ago, we have been awarded with Institute of Eminence. Institute of Eminence means there are 10 universities approximately, I guess, in India, which are being awarded with Institute of Eminence status, where Government of India provides 1,000 crore Indian rupees. I don't know how to translate it. Maybe I'll do it in the evening. Indian rupees for 5 years, such that they will jump into top 500 rankings. So, University of Hyderabad is ranked among 4th university in India. So, we have a 2,300 acres scenic campus, and we have more than 5,000 students, and we have different MSc, MA programs in arts, humanities, sciences, and engineering. So the picture is from our campus. So our campus is located, our university is located in, you can call it as a forest. So these are the pictures that are on the campus. We have a check dam where you have a lake. So we have peacocks, deers, and there is a dam here. So our university is a very beautiful university. So you'll know it once you visit here. So here it is India, and in India we are in the state called as Telangana, and so the capital of Telangana is the province capital is Hyderabad. So this is where the state is, the southern state of India, and so you need to travel from Europe to Hyderabad. Most of the flights are direct or otherwise. So the Delhi is here.
Bombay.
So the connecting flights are from Delhi, or so there is Mumbai here, or the connecting flights are from Mumbai. Okay, so let me, these are few glimpses of India. So once you visit here for research, find some time to look around. So this is about the research which I am doing here, a part of the research for the project, and I'm going to explain about it. So iron oxide nanocomposites, they are, we can say that there are vast number of applications, and when iron oxide nanoparticles are conjugated with carbon, so they find n number of applications. So carbon in the sense, so they can be activated carbon, carbon nanotubes, graphene, or RGO, we call it as reduced graphene oxide. And what happens when we add graphene to Fe3O4 is, so you could get number of functional groups that are available to it. So then when number of functional groups are available to it, then what happens is that, so you can use in multiple ways. So the applications will be more, and this spinal cubic structure of Fe3O4 is very useful. So these are the general applications. So Fe3O4 is used in CO2 reduction. So this catalysis application is very important, and so if you can reduce CO2 using Fe3O4, then most of the pollution hazards will come down, and woostite has higher activity of decomposing CO2 to carbon than that of oxygen deficient magnetite. So this is one of the application, and there are catalytic and environmental applications also. So Fe3O4 means that is having one of the best magnetic characteristics, and they have large surface areas, Fe3O4s, and they have very good stability for adsorption of biomolecules, capability of control and motion, and they can be used as anode materials in lithium ions. So they can be used for effectively removing water heavy metals from contaminated water. So here, so this slide says that so Fe3O4 can be used in drug carriers in the sense. So you can add drug into the Fe3O4 and inject into the bloodstream, and then send it to a place where there are some diseases, and you could clear the disease. So that is one of the application, and it can be used as anode materials also, and it can be used as water purification application also. So these are catalytic and environmental applications that are continued. So they can be used for heavy metal ion removals, sensitive photoconductors, and all this. So let me go to the synthesis now. So how are we making synthesis? So here in University of Hyderabad, we have a wet chemistry laboratory in my lab, and so we are trying synthesis of iron oxide nanoparticles in 4 different methods. So the first one is hydrothermal method, the second one is solvothermal method, and the third one is sol gel method, and the fourth one is microwave hydrothermal method. So we have one central facility called as microwave reactor, where we can heat the solution and turn on the system, and using the microwave heat, so that can be synthesized. So here I am just giving one example about how we are synthesizing it. So the one example which I am giving is hydrothermal synthesis of iron acetate for 4 hours. So what happens is that, so look into this, I think the diagram is misplaced. Let me go to the next slide. So the synthesis of graphene oxide. So the graphene oxide is synthesized by advanced Hammers method or modified Hammers method. And so everybody knows about modified Hammers method. So okay, let me explain it here. So what is given is, so we take concentrated H2SO4 and add 1 gram of graphite powder into it, and you take 500 a beaker and you stir it. So there is a specialty in the stirring. So you keep it in an ice bath. Ice bath means completely it is filled with ice, means the stirrer system, and in the middle, so you keep your H2SO4 with 1 gram graphite, and you keep on stirring it. So this stirring goes on for a minimum of 6 to 8 hours. It depends on the capability of the magnetic stirrer. And then what you do was, so you keep on adding, so NaNO3 0.5 grams and KMnO4 means potassium permanganate 3 grams, and you keep on stirring it. So once you have added potassium permanganate, and after 1 hour, so you add DI water, and so the first DI water is general room temperature, and after adding the first batch of DI water, again you add DI water. So that should be around 150 ml, and so that DI water is warm DI water, so around 45 degrees. So you heat the DI water and control the temperature for 45 degrees, and then you add into this solution. So once you have added it, again, let it keep stirring and mixing. So after that, so we should add 10 ml of H2O2. That is 30%, around 30% concentrated H2O2. So let it stir for 1 more hour, and then so you take the mixture, centrifuge it with high speeds, approximately 4,000 or 5,000 RPM for 15 to 20 minutes. And so keep on centrifuging it for 4 or 5 times. Then you'll get exfoliated layers of GO at 1,000 degrees. So you need to take it to a vacuum furnace, and then in the vacuum furnace, so you'll do it in 3 different methods. So the first one is we try to do in high vacuum. Then after that, we try to control it in nitrogen ambient, and then we try to do it in normal air ambient. So this is for comparison. So after this synthesis of graphene oxide, so what we do was we mix Fe3O4 and RGO. So by stirring it, means earlier we have synthesized Fe3O4 and now we got RGO. So we mix them and we keep on stirring it, and then finally we go for vacuum drying. Again, we go for the furnace which we have used for 1500 degrees centigrade, and then so somehow it is. Professor Dilian Jang, good morning.
Yeah, sorry, good morning. I'm sorry I'm late. I was
Professor.
up by another very urgent meeting, so anyway, I'm back now. Yeah, hello.
Okay. Okay. So somehow this is overwritten, I think, due to the compatibility between Apple MacBook and the Windows, it might be corrupted. So let me go to the Raman Spectra. So the first one is FEO, and the second one is RGO FEO, and the third one is RGO FEO RGO. So you could see that normally a material scientist know that Fe2O3 peaks are at 223, 283, and 1290, and FeOH peaks are at these places, and RGO 133 and 1584. So let me show you the RGO here, 133 and 1584, 133 and 1584. And these are the peaks, 223, 283, and there is a peak at 1290 here, or you could clearly see it here. So 1290, and the Raman spectra confirms that. So Fe3O4 particles are, O3 particles are there, and RGO is embedded in it. So this is about SEM images. So you could see the graphene, which is like flakes, and the particles here means RGO plus iron oxide. The particles here, the particles are embedded into the flakes, and this is the EDAX. So you could look into this. Normally for in every EDAX, so we see carbon. So this carbon doesn't mean that it is graphene. So generally when we are doing SEM EDAX, we'll keep it in a carbon film. So this is carbon. So Fe components are there. So this is not a strict evidence of Fe3O4, but at least it acts as a supportive data. So generally, RGO should be confirmed only by Raman Spectra. So this is our TEM. So this is the grid, and so if you look here carefully or here, so these are the graphene flakes, and over the graphene flakes, so these particles are Fe3O4. So the HRTEM clearly confirms that so Fe3O4 and graphene are perfectly mixed, and graphene is acting as an anchor for Fe3O4. So that means that Fe3O4 is going and sitting there. So these are the FTIR results. So COC bondings, CC bondings, and CO bondings, and so this area shows about RGO Fe3O4, and this is our famous Raman spectra, which we use to determine whether the graphene is clearly present or not. So the D and G peaks, generally the D peak is more pronounced than the G peaks. So it clearly shows that the presence of graphene in the composite. And now what we are trying to do was, so we are trying to make pellets out of these components, and then there will be two different sets of pellets. So the first one is like whatever sample we have received from China. So we are ball milling it, and we are making it as a fine Fe3O4 powder. And again, we are synthesizing graphene and adding into it. That is one set of sample. And the second set of sample is like we are synthesizing Fe3O4 in our laboratory and again adding graphene into it. So this is the second set of sample. So these two set of samples, what happens is that, so the second set of sample acts as a reference. So the first set of sample is our sample, which Professor Lewis has collected from steel plant in Peru, and that is processed, and it went to China, and again after China it came back to India. So to analyze the properties of first sample, we are making the second sample. So with this reference, we are comparing the first sample. So hope we'll complete it by this year. Mostly we are planning to complete it by September. And then, so if we can pelletize it, I believe this pellet can go as a raw material to the steel plant. So I thank the sponsors, kind acknowledgement to CONCYTEC, Foundation, and the World Bank. So we acknowledge the project number 012-2019 Foundation, and we are greatly thankful to the sponsors, greatly thankful to the project coordinators, Professor Angel Bustamante, Professor Deliang Zhang, and Professor Lewis. So thank you very much. So here is the end of my presentation. If there are any questions, I am happy to answer them. Thank you.
Okay, thank you very much for your talk. Now, if anybody has a question, please ask a question for Professor Pratap Kollu.
Yeah. Hello, Pratap. Yeah. Sorry if I missed the first, the major part of your presentation. And thanks for the presentation. Very nice. I think it's a good practice that every project meeting we have like a group presenting the most recent result. It's very good. Yeah, thanks, Luis, for the organization. Could I ask a simple question?
Yes,
from your part of work for this project, what's the most scientific value do you think we have got so far from the slag point of view?
Sir, I believe that whatever slag we are collecting it, we believe that there is more quantity of iron that is in that slag, and that iron could be retrieved. And so generally steel plants need pellet inputs. So for refining it, we can provide the pellet inputs. Then what happens is that whatever is the waste till date, so that is a useful input from tomorrow.
Okay. Oh, that's very good. You talk about graphene. So we intend to put graphene in the iron matrix, like a steel matrix, to make a composite. Would that be right? Or?
Yes, Professor. So actually, first of all, we will test with graphene. Now, why? Because for if you take steel making process, so in steel making process, what happens is that so there should be a combusting agent. So for graphene acts as a combusting agent without leaving any carbon black residues. Then what happens is that you will get a pure steel instead of carbon rich steel. So carbon rich steel has less value, and I believe you are expert in it, but I'm trying to say it. So if there is less carbon in the steel, so it is more valuable. So what happens is that, so instead of using general carbon additives as a combusting agent, so if we could produce graphene in less expensive method and use it as a combusting agent for the original steel plant, that would be more productive. So that is my opinion. Nice. Please correct me and suggest me.
Yeah, that's right. You know, related to this one is I think Peru also have got iron ores. You know, iron ores. Some iron ores is quite rich, very rich in iron oxide, and we could like use the solid state reaction process to extract iron. So if we could produce graphene as a byproduct, because carbon is used in as a reductant, you know, in the reaction. And I think perhaps even though it may not be a major part of the project, but we think about the extension of the project, so we may like start to do some pre-research, you know, think about this and then do some test. You know.
Yes, Professor. Actually, I haven't revealed it till date. So I spoke to one steel plant in India, Tata Steel Plant. So even I said that, so this is the project which I am working on. They said that, so if the project means if this is very successful, so they say that even we can apply patent for it, because nobody has developed a perfect recipe for making graphene Fe3O4 composite.
Yes, that's right.
Means as a pellet. So actually, means I have 3 students, but unfortunately, I am unable to push them. So this is a very good research area where we have a scope for patent, but I am requesting my students to do this since I am not paying them for doing this work. So they are doing their own PhD work. But anyway, they are doing it in evenings, Saturdays, Sundays.
Okay. Yeah, but yeah. Good. Thanks. Yeah. Thank you. That's my question.
Pratap Kollu. Thank you. Professor Ángel Bustamante also asking a question. Professor Ángel Bustamante.
Ya, Luis, mejor te lo digo en español para que lo traduzcas bien, ¿ya? La pregunta de question es la siguiente. El hierro está en el grafeno, ahí está como en la forma estructural dentro del grafeno, o está simplemente como una absorción, porque no mostró rayos X.
Okay, thank you. Pratap Kollu, Professor Angel Bustamante is asking whether the graphene, the iron into the in the graphene is doing any bonding, is like an structural, or how is bonding with how is bonding the iron with the graphene, or is an interlayer? Could you explain a little more about that, please?
Yeah, actually, this should be investigated more. But as of now, so what is happening is that graphene has functional groups on the edges, and so whatever Fe3O4 is there, so it is attaching to it. So regarding the bonding, I believe I could explain it more clearly in the next seminar. This one I am not perfectly sure about how it is bonding, but if I could see in FTIR, which gives the bonding things, so I saw that it is a composite, but unfortunately I couldn't comment more specifically about how it is bonding.
Okay, thank you very much. Any other question? Profesor Ángel Bustamante, yes, sí.
Solamente sería bueno medir por el spectroscopía Moss-Bauer.
Maybe with Moss-Bauer spectroscopy will be okay as well when you have the sample of Pratap Kollu and they can measure by Moss-Bauer spectroscopy.
Yeah, that would be more better, I think.
Okay. Thank you.
I'll send the sample.
Okay. Ya, va a enviar las muestras a Perú cuando los tenga todo listo. Perfecto. Gracias. Unfortunately, no more time for more questions. We need to continue with the program. Let me, before go ahead with the.
Okay, thank you, everyone. I am muting.
Schedule. Okay, thank you. Let me tell you some items which are necessary to mention. My visa here in China expires end of this month. Unfortunately, Professor Pratap Kollu, Professor Chandelier is helping me to extend my visa in China for some months more until the pandemic finishes. Supported with this project, supported because we have funding for this project for visiting. So supporting project for the CONCYTEC project, it is possible to continue, and then we are going to continue here because the University of San Marcos in this moment is closed. If I go to Peru next week, the university is for nothing because the University of San Marcos is closed now. Okay, well. Also, I need to mention that. Professor Ángel Bustamante has. We need to congratulate him because he won another funding from CONCYTEC. Is to do some superconductor project, and with that funding, he's very productive, Professor Ángel Bustamante. With that funding, he is buying some equipment, a new Raman spectrometer, an AFM, MFM, and evaporators, also some computers for the calculus, for simulations and so on. Okay, so it is good, and also he is going to send another student, Henry, another student, to come to to China, supported by the other funding, to visit Professor Chen. Professor Chandelian is helping us also to lead to accept the student with the other project to be here. With this project, it is supposed that the students Renato and Luis are coming when the pandemic finishes. Roughly, we estimate the beginning of the next term. Next term is September. So September, roughly, if the pandemic is already the third wave has finished, and so on, the vaccine injection program is completed and going well. Maybe September or October, September mostly, they are coming for sure to China. At that time, I will come as well with them. And they are. It's supposed the professor. Thanks to Professor Delian Zhang, he is agreeing that the students stay here for nearly nearly 1 year, the whole year, from September until August next year. Profesor Ángel Bustamante has his hand raised. Profesor Bustamante, ¿tiene usted su mano alzada? No. Okay. Yeah.
Question solamente.
No. Well, okay.
Según hay una conferencia de Latin American Conference on Apply ¿cómo se llama? Molecular Spectroscopy en Brasil next November. Maybe to go at this conference in Latin American to show the Molecular spectroscopy to several samples we contain iron. I think there is a interesting that the students go to the present several works. In Espíritu Santo, en Brasil. Luis, hay esa conferencia de Molecular en Brasil.
Okay, then Professor Bustamante, could you send us the link by email, please, in order to try to register with the students and so on to participate, because there are some funding for participation in conference. Okay.
Luis, only one thing. Professor Bustamante, I know that Congress, la CAME, la Latin American Congress on Molecular Spectroscopy, is going to do the next year on November. Not in this year. I know that it will be on the next year, 2022. Okay.
Okay. Yeah. Well, don't worry. Thank you for information, Marlon. Maybe we are going to look for another conference also to participate this year or so, or beginning next year or so. Well, okay. Another thing is that thank you. Another thing is that from now on, please, we are going to have, because we are running on time with the project end of this year. However, depending of our progress until December this year, the CONCYTEC might give us a chance to extend for 6 months more the project, but only for finishing, but not giving any more funding, That is why the students, if they come in September, they can stay until August next year, okay? So from now on, because of that, we are running on time. We are to have 2 meetings every meeting, similar like today, one of the members is going to give a talk about their progress. Similar that today, Professor Pratap Kollu has given a talk about his progress. Next meeting, for example, will be 6th of April. We are starting from India. Dr. Narsiboy is going to give a talk 6th of April. 6th of April, Narsiboya is going to give a talk about his progress. Okay, Narsiboya, are you taking note?
Yeah, yes, sir.
Okay, 6th of April, please. You are going to give a talk about your project. Then, after that, Narsiboya is going to rest and continue progressing, and end after some months more, later, I don't know, September, June, July, I don't know, is going to give another talk as well. Please remember that every member needs to publish a paper, and in the paper, every member needs to publish a paper, and the paper should appear one of the affiliation of the University of San Marcos. Okay, according to the CONCYTEC, one of the requirements, one at least per member, one. Also, if you would like, will be very, you, for example, you are, for example, in India or in China, I don't know, if you write affiliation, if your institution forbidden you to write another affiliation, maybe you can add Professor Angel Bustamante, or to me, for example, whoever, Professor Angel Bustamante at the affiliation of San Marcos, and that will be solved. Okay, maybe if it is, or maybe you can add also another affiliation. And in the acknowledgement part, in the acknowledgement section, you need to acknowledge the funding, this funding from the CONCYTEC. Okay, for example, just give an example. Professor Shaoli Shao, Professor Shaoli, are you there?
Yes,
yes, I'm here. Yes.
Okay. For example, at this moment, Professor Shaoli Shao is doing a manuscript, something related with iron, with powder oxides, or whatever thing. For example, what I recommend is by end of this year, for example, if she acknowledges in one of her papers she's doing with one of his with her students, they acknowledge the funding, and also the affiliation, maybe adding Professor Bustamante or to me, whoever, will be very nice, because no need to write a specific paper related with the project, because it will be very tedious. Okay, but if you if you add one of the papers that you are progressing now, something related with oxide of iron oxide or whatever, if you add the acknowledgement of the project, will be very nice. Up to now, we are publishing 2 papers that last year, 2 papers. One paper we have published in one spring year, and we acknowledge it's my name, Professor Angel Bustamante as well. Also, another paper which has been, I don't remember, is in Elsevier, but my name is also there, but I acknowledge there with other collaborators, following this strategy that I am telling you. And CONCYTEC accepted last year, so no problem in my side. In this year, Professor Delian Shang is submitting 2 papers, the Yanendra papers, by the way, Yanendra papers. One paper is already with minor corrections. That paper, unfortunately, is not Shimago, but it's in Scopus. And the second paper that we have submitted to one journal appears in Shimago, has Shimago qualification. So and it's under process now. So Professor Delian Shang is acknowledging in this moment he has submitted 2 papers. His acknowledgement is doing the process that no problem with him, because he's doing the process that CONCYTEC wants. Okay, for the rest of the members, don't forget the rest of the members need to present a paper, minimum a paper. Okay, Professor Pratap Kollu, Dr. Narsiboy, at the end of the project, remember a paper, and you need to keep the progress of your paper so far to the next or your work to the next one. Okay, that is the CONCYTEC one. Yes. Okay.
Could I interrupt? Sorry. Is this essential for the papers to be SCI, to be published in the SCI journals, or can we publish some papers in like EI journals? Or?
As CONCYTEC says, as long as it is in Scopus, it is fine. As long as it appears in Scopus.
Oh, as long as in Scopus. Scopius.
Yes.
Okay. Because I'm, as Xiaoli know that I'm an editor of a journal called Heat Treatment and Surface Engineering. Because heat treatment of materials, it could be related to reductions, very. But unfortunately, that journal is not yet SCI journal. I think it may get into Scopus soon, but we'll try. Yeah. But it's published by a quite reputable publisher called Taylor and Francis. Taylor and Francis.
Taylor and Francis.
That's a big publisher. Okay. And so they're supporting it. And so we might, like our group, may select, one, like 2 or 3 papers, manuscript, to be submitted to that journal. One, to support that journal. Secondly, it will be very quick to publish in a way, if the quality is good, But the manuscript, ideally, the manuscript does not have my name on it, like if but could be if it relates to my students' work. Obviously, I should be on it, but then another editor would look after it. So that sort of thing. Yeah.
Okay. Thank you. So, Professor Delian is recommending another journal who is the editor. It's Francis, Taylor and Francis. Okay. Yeah. Okay. We need to move ahead. Okay. That was about the paper because we are on time. We are on time now. Okay. So next meeting, Narsiboya. Now, very quickly about just not need a presentation, but just mention the progress of everybody. We are going to start with Dr. Marlon. Marlon, very shortly, please, in 1 or 2 minutes, about your progress.
Okay. Good afternoon. Actually, I'm working with in mobile